Part D of Module 3, Empirical Analysis of Algorithms, and Project 1. D.1, first, we look at this general empirical analysis of algorithms. Then I will give you the description and some technical points of our Project 1. Later, I will post the description document soon. Yeah. All right. So actually, for all our programming algorithms, we do empirical analysis. So let's look at some basics about the empirical analysis of algorithms. Yeah. So far, when we study the efficiency of our algorithms, we do mathematical analysis. Yeah. And we know it is very powerful. So we can use a lot of math tools to derive many formulas. Some formulas could be very complicated, yeah. But still there is a limit there. Yeah. Something you cannot do. So a lot of things actually you cannot do, you cannot solve, or even nobody can solve. There are so many things like that. Okay. Yeah. So if you look at the equations, there are a large number of equations nobody can solve. Okay. Yeah. Although right now people can use computer to find approximations. Yeah. So computer can do approximations. But if you want to do exact analysis, large number of problems, nobody can solve. Okay? Yeah. So considering those big limitations, so then if we cannot solve those problems mathematically, what should we do? Right? We need to do something. Yeah. Yeah. In the real world situations, many times nobody can solve some of the problems. But we want to get an idea. How efficient is the algorithm? In that situation, one thing we can do. So we can always do empirical analysis on this algorithm. We can write programs, do experiments, and collect results. Then we do some analysis, data analysis on our results. That can be done all the time, right? Yeah. So for that reason, you can see the empirical analysis is useful. At least we can say it is useful. Yeah. But in this class, that is our secondary consideration. Our first or primary consideration, still mathematical analysis. Yeah. All right. Yeah, so although we say theoretically we can always do empirical analysis, but it does not mean it is easy. Yeah. You really need to do some non-trivial work if you want to do good empirical analysis. Yeah. Here we want to see what kind of work we need to do. Yeah. So how to do empirical analysis? I just select some key points we need to do. Yeah. The general plan. Yeah. First, we need to understand experiment's purpose. Yeah. So usually we know, yeah, if we already have some algorithm to solve some special problem. Yeah. So we know what we want to study. Yeah. Then we design our experiments. You need to design. There are many different ways to do experiments. Yeah. So in your design, you need to provide answers to these questions. What operation is used as the basic operation? Usually, this step is pretty easy, pretty straightforward. Yeah. Only a small number of operations. Yeah. And if you like, you can keep track of all those operations if you like. Okay, yeah. How to set up a counting variable. Yeah, because you need to do counting. You need to count the number of operations. How do you describe efficiency? Usually we use the number of operations. So you need to use counting variables. But you need to find the right way to use your counting variables. Yeah. So that's another question. Yeah. All right. Yeah. Another question you may need to ask yourself, do you need to use the real execution time to measure efficiency? In our mathematical analysis, we do not use that. In our mathematical analysis, we know execution time is not a reliable measure of efficiency. For different computers, for different algorithms, for different, programming skills, that could be different, right? Yeah. But now we are doing empirical analysis. That measure is a useful one because we only work on our own computer. You only work on one computer, fixed computer. Yeah. So we can assume the computer is fixed. Yeah, we always use this computer. Okay. So you do experiments many, many times on this computer. Then you can compare the execution time because it is a straightforward measure. Especially when you have different experiments, designs, then it's a straightforward measure to do comparisons. So we need to use it. In our project 1, we will compare it. We will use it. Execution time. Okay? Yeah. All right. Yeah. So then, another thing you need to consider, decide on the characteristics of the input sample. For our project 1, we don't have this issue. Yeah. Because our project 1, the input, only one positive integer. We do not need to study any characteristics, right? Yeah. But in our project 2, and then later if we have time, we can do project 3. Yeah, but here there is a possibility we may not have time. Yeah, so let's try. So given an array, then there is some characteristics you need to consider in your input data. For example, your array is already sorted in ascending order or sorted in descending order, or it's a random array, or you can put some special characteristics for your input data. Then you do experiments. The result will be different. So you can compare execution time. Okay? Yeah. So things like that. All those things you need to put in your design. So you can see it is really not very trivial. Yeah. You really need to do something very special. Okay, yeah. After that, after you consider many problems, so then you can write your program to do the implementation, yeah, and collect results. After that, do some analysis and make conclusions at the end. Typically, so we follow the procedure like this, yeah, for empirical analysis. Yeah. All right. There is another, yeah, there is another, yeah, so I already finished these 2 points, but another interesting aspect of empirical analysis. Yeah. Most of the time people do not do that because it is relatively hard. Okay? But sometimes some people like to put more time on it. Then it is also nice. So that is algorithm visualization. You make your experiment results that could be visualized. Okay? So you produce some graphics, statistics, and some graphics, some way people can see good or bad quickly. Okay? So that is another interesting, useful method, visualization. Yeah. But definitely for our project, we won't do that. Yeah. Because too time consuming. So we don't have that much time to do this. Yeah. But here I like you to know this way is pretty interesting. Yeah. All right. There are 2 ways to do algorithm visualization. The first way is static algorithm visualization. Yeah. So after you collect statistic data, you just produce some graphs. Yeah. You need to design some nice way to present your data, but it is static. You put data there, it stays there forever. Okay? Yeah. Just one whole picture of your data. Okay? So people can see something, yeah, get some information, but no change. Yeah. Stay there forever. Yeah. But the second way, more interesting, dynamic data visualization. So this one is more interesting. Yeah. So that means when you design this kind of visualization, you need to be more creative. How do you produce this kind of dynamic visualization effect? So that's non-trivial. So you need to be very creative. Yeah. But if you can do that, then it will be very impressive. So when people see that, wow, a very nice way to convince people which algorithm is more efficient, Yeah. So that kind of thing, yeah, very useful, yeah, but pretty hard, yeah. All right. So I can give you one example about that. I just described that example, yeah. A classic example. So that example, many people like that. Yeah. Someone produced that dynamic visualization called sorting out sorting. Yeah. Compare 9 or 15. Yeah. So here, why 2 numbers? The early version, yeah, because this one has several versions. The early version, 9, compare 9 sorting algorithms. So then the newer version, 15, different sorting algorithms. Yeah. and produce a video. So when you sort the data, so you can see when you run, because when you sort data, you need to do comparison, right? One comparison after another one. So when you do that, so you can see the data sorted in a dynamic way, for comparing several different algorithms. So there is a video, YouTube, you can find that video, okay, easily. I found that. So last semester I show here, but so this semester I do not show that because I feel the video quality is not very good. The resolution, the picture, the quality is not very good. If someone can produce a high quality video for this one, so then it will be very nice. So when we look at it, so you will enjoy it. But with a low quality, so I don't like to see it, things like that, All right, so that's the empirical analysis. So that topic. Next, we get to our project 1. The topic, task we need to do, calculate Fibonacci numbers. We just learned it. We spend a lot of time discuss how to solve this problem, find the Fibonacci numbers. We use 2 parts, part B, part C, to solve this problem. Okay, so now we need to do a project, try to compare the efficiency difference of bad algorithm and a good algorithm. 2 algorithms, we compare their efficiencies. All right, so the goal, compare efficiencies for different implementation algorithms. The general goal. But what 2 algorithms we will compare? The first one we choose, straightforward recursion algorithm. We know that, right? So that one, I give the page number in our PowerPoint slides, notes. So you can find it easily. The code is very short. So you can write it easily. But we want to do the experiment. We want to compare how fast it is. So we check the execution time. Okay, so that is the bad one. So this one, that's our bad one. Then, good one. Good one. Change to an efficient algorithm. We have a good one, right? So we have several good one. But for this project, I only like you to pick one easy good one. Iterative. So we have iterative. No recursion, right? No recursion. Iterative. But no redundant calculation. So that one pretty easy. The code also very short. So that makes the project too easy, right? So although from algorithm point of view, it looks so easy, right? Not much work to do, but when you work on it, you will have a new problem you need to consider. Overflow problem. Overflow problem. That is a big problem here. So think about when you work on Fibonacci numbers, eventually you will get overflow, right? So the data type, the integer data type you use cannot hold that large Fibonacci numbers. So the overflow is a big issue. Even worse, when you have overflow, you don't know it. You don't know it. You don't know you get overflow. Because when you have overflow, there is no error message. No error message. So you don't know the number you get is a wrong one. Yeah. When you get overflow, truncation, right? So inside computer, yeah, because some digits are out of the bound. So for the out of bound portion, truncate it. So using the remaining to do the calculation. That's wrong answer. But how do you check it? How do you know it is wrong? How do you detect it? Yeah? Here you can see there are many technical problems. Yeah. So how to solve it? Yeah. So that's the something interesting I want to put in this project. When you work on the real world problems, you will have some new problems. So it's not the mathematical problems. It is a practical problems you need to solve. Yeah. So this overflow one. Okay? Yeah. And we want to overcome that. Yeah. So in this project, I don't want you to stop before you get overflow, right? Before you get overflow. Or you do a little more, you can detect when you have the overflow, then you stop. Yeah. I don't want to just do that. Not enough for me. Okay? What I'd like you to do, you need to overcome that overflow problem. Okay? Yeah. Yeah. Overcome that overflow problem. Yeah. In my next video, I will give you the way to overcome. Yeah. Yeah. So you will find a way to overcome it. Yeah. Not very complicated. Yeah. Actually pretty easy. You have a way to solve that overflow problem. So in my video D.2, I explain that method. Yeah. All right. After that, yeah, so now we can assume we fix that overflow problem. Right? In that way, we can calculate very large Fibonacci number, or Fibonacci number for large data size. Data size n, right? N is the data size. The magnitude of n, that's the data size. And we can work on pretty big data size Fibonacci number. And we can get the answer quickly. Okay? So the performance difference is very big. So I want you to compare. Bad one, very slow. Good one, very fast. Huge difference. So that's what I want to convey in this project. All right, so let me stop. D.1. Yeah. Next, I will use D.2 to explain the overflow problem. Then D.3, I will talk about another problem in our project 1. All right, yeah.